I thought it worked out very nicely. So the other day I was writing some kind of analysis, basic blocks, computing weakest preconditions and whatnot, and I started with a data structure like that. So you have basic blocks which have statements, and then they point to some other basic blocks, and then statements, or it doesn't really matter what, some assignments, and assertions and assumptions, and you can put many statements together, so you essentially have a list of instructions. And then the expressions are just some kind of generic first-order term, some sort of a function symbol applied to a bunch of expression or variable. Properties are very similar, a predicate symbol applied to a bunch of expression, or a connective applied to a bunch of other properties. Right, so this is a very basic data types, and here I defined all the labels, variables, functions, all to be string. Okay, but that's not great, and I was thinking, how can I make this a little bit more generic? So I wanted to parameterize it so that these things are not all string, but different ASTs can use different types for that. Okay, and so the naive way to do that in Haskell would be to basically, well, parameterize the data type by all these types. So you get that, right? Here's a block, and it's parameterized by L, V, F, P, and C. You know the type of label, variables, function symbol, predicate symbols, and connective symbols, and you kind of pass them all over the place, but the code looks horrible, right? So you have so many parameters. And so then I thought, well, what do we do when we write normal code? Usually when you have so many parameters, you might want to put them in a record. Okay, so this was the basis of the trick, is to implement a little type level record, and I did that with type functions. So this here is how I did it. Basically, parameterize everything by just one thing. Okay, L, this is the name of your record or the name of your little language. And then everything is parameterized by L. So, you know, blocks are parameterized by L, statements are parameterized by L, and so on. And notice that now we have this label L or var sim of L, so which are just the same as the type synonyms before, but now they're parameterized by the L. Okay? So what are these things? Well, those are just type functions that would tell you for the specific language that you're using what are the variables, predicate symbols, and so on. Okay? So here are all the types, and they look pretty simple. Okay, so I didn't implement them exactly as types and symbols because for my analysis, these things did not need to be, well, couldn't be completely opaque. So I needed to know, for example, how to write equality in math. So I needed some assumptions about these things. So instead I packaged them in a type class called language. Okay? And so basically in this type class called language, I wrote all the symbols, all the names I essentially need for my algorithm. Okay, so I need to know how to say equality, and then there's some invariance, doesn't matter what it is. I need to know how to write the conjunction symbol, and I need to write the imply symbol, and I need to write true. Furthermore, I need ordering on the variables and ordering on the labels. Right, so basically I have a custom class, and I named all of this thing language. And once you have that, you can define, you know, because it's a pain to use these things directly, you can define some syntactic sugar. So in any language, I can say, okay, give me two expressions and I'll give you a property. Give me two properties and I'll give you the conjunction of them. So it's just a little bit of syntactic sugar to use in the algorithm. Okay, and so this is pretty much the idea. Basically, you kind of, when you want a type level record, you can have just some type. It doesn't really matter what it is, and then you define type level functions to define the fields. And okay, I've run out of time, so I'll just show you some of the types. So just look at the types. The definitions don't really matter. Okay, so here is, oh, that's boring. All right, so here is the type of dominators. Give me a language and a function in the language, and I'll give you a map that for each basic block, it gives you the set of labels that dominate it. And here is identify natural loops. That's some other algorithm. Give me a function and an edge, essentially, identifying the loop, and I'll give you the set of labels identifying the blocks in the loop. And so they're all like pretty reasonable types, really. Anyway, so this is just a simple trick that you might want to use in your programs.
So hi, I'm Joey Hess, and I'm going to evaluate this talk a little lazily since we're still getting the video set up. This is my first Haskell Symposium. I'm talking about my second Haskell program, which is called Propeller. The first one was GetAnnex. So, you're probably going to have to show me what to hit here.